Hi everyone. So today we will discuss projectile motion, and projectile motion, it is part of motion in a plane. When we say motion in a plane, it means it can be two-dimensional motion, it can be three-dimensional motion, or it can also be one-dimensional motion depending on certain circumstances. So in general, projectile motion, it is a case of motion in two dimension. It means the particles move simultaneously along x-axis as well as along this y-axis. So if a particle moves along x-axis and y-axis simultaneously, then that type of motion, that will be termed as motion in a plane. Like circular motion, it is also a case of motion in a plane, and similarly here projectile motion, it is also a case of motion in a plane. So if you consider that suppose a particle is thrown with some velocity u at an angle of theta. So if it is thrown with some velocity u at an angle of theta, so it will start moving along x-axis with the component u cos theta and u sin theta. U cos theta along the x-axis, u sin theta along the y-axis. U its point of velocity of projection. So suppose it is projected from the point O. Let us say the particle is projected from the point O. Initial velocity of projection, it is u, and angle of projection, it is theta. Now here three physical quantities are acting on the particle simultaneously. One is it is moving with the velocity u cos theta along x-axis. Another, it is moving with the velocity u sin theta along y-axis, and simultaneously as it is thrown, and it is thrown under gravity, so it means acceleration due to gravity, simultaneously it starts acting on it in the downward direction. So this velocity tries to move it up in the upward direction, g simultaneously tries to bring it down, and u cos theta tries to move it along x-axis. So these are the three things simultaneously acting or working on the particle. So because of the presence of this u cos theta, u sin theta and g, now here you can see along x-axis there are no forces acting, and when there are no forces acting on the particle along x-axis, it means the velocity will remain constant, because if there are forces, either accelerating force or a retarding force, then only there will be change in the velocity, only then we will have acceleration of the particle or retardation of the particle, and because of that the velocity will change. But along x-axis here, in this case, no forces are acting, so it means this velocity u cos theta will remain constant throughout the motion. But u sin theta, you can see, this is the initial component of the velocity along y-axis, velocity of projection along y-axis. So at this point it is suppose u sin theta, but simultaneously g is working on it in the downward direction, so it will try to retard the motion. It will try to decrease the velocity, it will try to retard the motion. So u sin theta here it becomes variable because it is not constant. U cos theta is constant because there are no forces acting along x-axis, and because of this g, there will be at every point of time there will be change in the velocity u sin theta. So taking consideration of all these three factors, u cos theta, u sin theta and g, the particle will try to move up, at the same time it will move down. So it means if you consider this, then the particle will follow this path. So in general, this is parabolic, this curve is parabolic in nature, and this is termed as trajectory of the projectile, that is the path that the particle follows. So in general we call it as the trajectory of the projectile, and nature of this trajectory, it is parabolic. So this is parabolic in nature. The curve is parabolic in nature. Now here see why it happens, because u cos theta, it is constant, so it will keep on covering the horizontal distance with the constant velocity u cos theta. It will try to move up with the vertical component u sin theta, but it is not able to move continuously in the upward direction. Simultaneously it is moving down due to this g. That's why you can see this curve. Then slowly and slowly the motion gets retarded, and finally at some point it becomes zero. Means the y component of the velocity at some point becomes 0, and as soon as the velocity, y component of the velocity becomes 0, it will start moving in the downward direction. So the point where the y component of the velocity becomes 0, that becomes the point of maximum height, because the particle is moving up, goes up to that particular height, attains 0 velocity as far as the y component is concerned, and then it starts moving in the downward direction. So let us say the particle attains its y component of the velocity 0 here, so that Vy at this point, it will become 0, Vy becomes 0. So the point where y component of the velocity becomes 0, that is termed as point of maximum height. Point of maximum height. From this it will start moving in the downward direction, because initial velocity at this point becomes 0, g is continuously working on it, so it will try to move this particle in the downward direction, so it will start moving in the downward direction. Now g, beyond this point it becomes acceleration. Till this point it was behaving as retardation, because it was trying to retard its velocity. As soon as it attains 0 and then it starts moving in the downward direction, so g starts behaving as an acceleration, and because of this again its velocity will start increasing. So in this direction again the velocity will start increasing. Here it was slowly and slowly it was decreasing, and finally it has attained this 0 velocity as far as the y component is concerned. This will be termed as your maximum height. Now the particle has covered some distance, from this point to this point, as well as from this point to this point. This is the elevation of this point is same as the elevation of this point. Let us name it as O dash. So OO dash, it is parallel to the ground surface, means OO dash, it is at the same level. So if O and O dash is at the same level, then the distance covered between O and O dash, it is termed as range of the projectile. This is termed as range of the projectile. So this becomes the horizontal distance covered, that is termed as the range of the projectile. The vertical distance covered till its velocity component becomes 0 as far as the y component is concerned, that distance covered becomes the maximum height. Now from the point of projection to the maximum height, time taken by the projectile to reach this maximum height from the point of projection, that is termed as time of ascent. Ascent because it is moving in the upward direction, it is ascending, so time taken, it is termed as time of ascent. So this time taken from this point to this point, that becomes your time of ascent. Okay. From the maximum height back to the same elevation, that is O dash, it is now in the descending order, it is moving down. So time taken here from this point back to this point, that becomes your time of descent. So this journey, time taken, it is time of descent. So we have this time of ascent, we have this time of descent. This is your range of the projectile, and this becomes the maximum height. These are the parameters that is generally, or that generally comes across this projectile motion. The maximum height, the range of the projectile, initial velocity of projection, angle of projection, time of ascent, as well as time of descent. So I hope all these terms are clear. Y component of the velocity at this point it is 0, but x component remains same as u cos theta, because here if you say y component of the velocity Vy, that becomes 0, and x component of the velocity here, that will remain same as ux is equal to u cos theta. Okay. This point, at the point, maximum height point, if you draw a tangent, at this parabola, at the point of maximum height, that tangent becomes parallel to x-axis. So this line here, it is parallel to x-axis. Now let us, one by one, let us calculate the values of this range of the projectile, the maximum height, time of ascent, time of descent, and all these parameters. See, so these are your point O dash at the same elevation. P is the point of maximum height. This distance covered is H max. Time of ascent, let us say it is TA. A stands for ascent, and time of descent it is TD. So the total time of flight, the particle is in air from the point O back to this point O dash. That will time taken throughout this journey from this point O back to this point O dash, that is termed as time of flight. So time of flight. And that is suppose capital T such that T is equal to TA plus TD. Time of ascent plus time of descent. Time of ascent is same as time of descent, because this point to this point and again back to the same elevation, that is O dash. So nature of the journey it is same, trajectory it is same. So time of ascent this and this time of descent it will be same. So we say TA is equal to TD. So time of ascent and time of descent it is same. Now let us calculate all the parameters one by one. So first see, as far as, because here we are considering motion in a plane, that is two-dimensional motion. One dimension is because of this velocity u cos theta, another direction movement it is because of u sin theta as well as this g. Now here the velocity, y component of the velocity at this point vy, it becomes 0, and ux that remains same as u cos theta. So y component of the velocity it is 0. So can you say vy is equal to uy minus gt. This is the general expression as far as the motion along linear direction is concerned. So if you take this y component of the velocity, so vy is equal to uy minus gt. Now vy is equal to 0 when t becomes what? Time of ascent, means when the particle has reached its maximum height. So this will be 0. So this becomes your uy minus gta. So from here you can calculate time of ascent, that is equal to uy upon this g. Y component of the velocity, initial y component of the velocity divided by this g. Now initial velocity along y direction is how much? U sin theta. So this becomes u sin theta divided. So time of ascent it becomes u sin theta. We have just discussed time of descent, it is same as time of ascent. So this is also equal to time of descent. So the total time of flight, that becomes how much? T is equal to TA plus TD. So T is equal to TA plus TD. TA plus TD, and can we directly write this is u sin theta upon g plus u sin theta upon g. So you can see it is 2u sin theta upon this g. So this is the total time of flight, 2u sin theta upon this g. So we have calculated time of ascent, time of descent, and the total time of flight. Now consider the maximum height. For maximum height, the y component of the velocity is 0. So can we use this equation vy square is equal to u square minus 2gh. When we have to calculate the distance, so we can consider this equation vy square is equal to uy square minus 2gh. When h is h max, maximum height, y component of the velocity becomes 0. So we can write 0, it is equal to uy square minus 2gh max. So this gives you h max is equal to uy square upon 2g. Again uy, initial velocity along y direction, that is u sin theta. So can we write this as u square sin square theta upon this 2g. So this is the maximum height. Maximum height, that will be u square sin square theta upon 2g. So this gives you the maximum height, and we have calculated time of ascent, time of descent, and time of flight, the total time of flight. Similarly, the range of the projectile. This is the range of the projectile. This is your u, this is theta, this was your maximum height. here y component of the velocity at this point it is 0, and we have used this concept. Now range of the projectile, so this point is our O and this is O dash. Range of the projectile O dash, O dash is what? It is nothing but the horizontal distance covered during the total time of flight. Total time of flight from this point to this point to this. That was the total time of flight. During that time, the particle has simultaneously covered this horizontal distance r with the horizontal component of the velocity u cos theta, because this component of the velocity it is u cos theta and this side it is u sin theta, and you have this g. With this velocity, it has covered this r in the total time of flight t. So can you say r, it is equal to u cos theta into total time of flight, and total time of flight is how much? Twice of u sin theta upon g. So it is u cos theta into twice of u sin theta upon g. So this becomes the range of the projectile. So if you solve it, you will be getting it as 2 u square cos theta into sin theta upon this g. Now 2 cos theta sin theta, that becomes sin 2 theta. So from there we can write r is equal to u square sin 2 theta upon g. So this is the range of the projectile. This is range of the projectile, this is maximum height. We have already calculated time of ascent and time of descent. So this way we can calculate range of the projectile. So we have calculated this, we have calculated this, we have calculated time of ascent, we have calculated time of descent, and we have calculated total time of flight. Now if you consider r is equal to u square sin 2 theta upon g, r is equal to u square sin 2 theta upon g. Now see this, a particle is thrown with the initial velocity of projection u at some angle of projection theta. Now if someone, a thrower, would like always to have its maximum range, it means it will depend on his energy, because energy means with what initial velocity he can throw the particle or the object. This clear? At what angle? So angle, it depends on how much rotation he can create as far as his hand is concerned, his or her hand is concerned. So theta depends on us, but u depends as far as our energy level is concerned, our stamina is concerned. So depending on stamina, that suddenly we can't change. That is a constant for a particular person, it depends on his stamina. This guy, but theta, it can be changed at any point of time, because theta, it depends on at what angle we are throwing the object. It means if you consider, if you throw a particle with the velocity u at an angle of theta is equal to 45 degree, in that case you will get the maximum range. The horizontal distance covered, it is maximized depending on at what angle you are throwing the object. So you can consider R max is equal to u square upon g. U square upon g, because if theta is equal to 45 degree, this implies 2 theta it will be equal to 90 degree, and when 2 theta is 90 degree, that means sin 90 is equal to 1, and when sin 91, that is the maximum value of that trigonometrical function sin theta. So sin 90 is 1. So we have maximized this. We can't change the value of g. Again, it is constant. We can't change suddenly the value of this u. For that we need to increase our stamina. But theta depends on our orientation of the hand. So that can be changed, that can be varied. So we can throw the object at an angle of 10 degree, 20 degree, 40 degree, 45, 50, anything. But if you throw it at an angle of 45 degree, 2 theta becomes 90 degree. That gives us sin 90, which is the maximum for this trigonometrical function. So we can maximize. So in that case we get the maximum range u square upon g. So we have this maximum range, we have maximum height, we have maximum height does not correspond to maximum range. That is a different concept, and here this R max, it is a different concept. We have calculated time of ascent, time of descent, as well as the total time of flight. Now let us see what will be the equation of this parabolic path. The equation of this curve in general, or this parabolic path in particular, or trajectory of the object. the trajectory, the path that it follows. So let us see how this equation is calculated. See, equation of any curve in general, it is nothing but a relation between x and y. So if you can generate an equation y as a function of x, so y as a function of x, that gives us an equation. If y is a function of x and if it is linear in nature, then that equation represents equation of a straight line. But if y is a function of x and that equation is quadratic, cubic or any other, it means that will represent a curve. Is clear? So when it represents a curve, and here you can see it is parabolic curve, so we have to calculate the equation of this parabola. Now when we need to calculate equation of the parabola, it means we have to develop equation between x and y. We have to develop equation between x and y. So suppose take this point, let us say P at this point. So particle is at the point P after some time, suppose t. So after time t, let us say the particle has reached to this point P. So what will be the and x component of this point is x and y component is y. Any position, if you represent the position, say along x-axis it has covered a distance of x, along y-axis it has covered a distance of y in this time t. T is not time of ascent or time of descent, this is any time t. So the particle has started moving from this point O, it has reached this point P after time t, covering a distance of x and y along x-axis as well as y-axis. So x will be equal to how much? X is equal to u cos theta into time t. And y is equal to how much? Y, that will be equal to your u sin theta t and minus half gt square. These are the x and y coordinate, x equal to u cos theta t and y is equal to u sin theta t minus half gt square. Now we need what? Just to develop equation of this curve, we need y as a function of x. A relation between x and y, but this relation is between x and t, this relation is between y and t. So if we can eliminate t from here, from these two equations, if we can eliminate time t, we will get a relation between x and y, and that relation between x and y will be the equation of this parabola, because x and y lies on this parabola. So when x and y, this point lies on the parabola, and if we can establish a relation between x and y, that means that represents the equation of the parabola. So that's what we will do here. So from here, can you say this t, it is equal to x upon u cos theta. T is equal to x upon u cos theta. So putting the value of t is equal to x upon u cos theta, we will get the value of this y. So from here, can you write this y? Let us write it here. Y is equal to u sin theta. T we have to replace by x upon u cos theta. X upon u cos theta. Minus half g t square, means x square upon u square cos square theta. Now you can see t has been eliminated, we have only u as well as x, because theta is a non-quantity, initial velocity of projection, that is also a non-quantity. So we have a relation between x and y, and that x and y lies on this curve. It means it represents, and this equation represents equation of this trajectory in general, but we know that this path is parabolic in nature, so this will be, this equation represents the equation of the parabolic path that the projectile or the particle follows. So we can arrange the term and we can write this y is equal to x sin theta upon cos theta, that will be tan theta, this u and u is cancelled, so it is x tan theta, x tan theta minus half g x square upon u square cos theta. So minus half g x square divided by u square cos square theta. So this is the equation of the trajectory, equation of the parabola in particular, or equation of the trajectory in general. So we have learnt how to calculate equation of this parabola or equation of the trajectory. Now see this, all these discussions we have done, But what is common in calculating time of ascent, time of descent, total time of flight, range, maximum height, or the equation? It is just the linear equation or the kinematics along x-axis and y-axis simultaneously, because it is a case of simple kinematic motion, provided you simultaneously take it along x-axis and y-axis. The particle is simultaneously moving along one dimension with the u cos theta. It is moving simultaneously along y direction with the velocity u sin theta. So as far as these relations or these formulas are concerned, if you consider my suggestion, there is nothing to remember. Simply consider this movement along two directions. And when we say movement along two directions, so it should be simultaneous. Simultaneously, you consider this initial velocity u cos theta, initial velocity u sin theta, acceleration due to gravity acting along y-axis. Now, just use the kinematic equation, calculate distance covered in time t by the particle using the simple kinematic equation as we have used here: x equal to u cos theta t, y is equal to u sin theta t minus half dt square, using s equal to ut minus half at square formula. So this way you can calculate any of this. When we were calculating range of the projectile, it was what? X component of the velocity into total time of flight. So u cos theta into t. So that is nothing but s is equal to ut. That is the thing that we use in the simple kinematics. So that way we have calculated range of the projectile. Time of ascent we have calculated what? V square is equal to u square minus 2g. Vy is equal to, or v is equal to u minus gt or u minus at, depending on whether it is a case of acceleration or retardation. When it was time of ascent, we have put y is component of the velocity 0 and we have calculated time of ascent Ta. Time of descent, it is same as time of ascent. So once we have calculated time of ascent, already that gives us the value of time of descent. Total time of flight is what? Nothing but the time of ascent plus time of descent, and that gives you that relation. So I don't think there is anything to remember as far as this motion is concerned. Just use the simple kinematic equations along x-axis and y-axis simultaneously and calculate whatever is desired or the required quantity. So I hope this is clear, and we will discuss problems based on this concept, that is motion in a plane and particularly the projectile motion. Thank you.